Have you ever wondered what the next giant leap for the internet will look like? We've gone from dial-up to fiber optics, but what comes next? Get ready, because we're on the brink of a revolution, one powered by the strange and wonderful rules of quantum physics. This is the story of the quantum light revolution and how it is about to completely transform our network systems. So, what exactly is this quantum light revolution? To understand it, we need to talk about photons, the fundamental particles of light. In our current classical networks, we send information by encoding it into pulses of light, containing billions of photons. Think of it like shouting a message across a crowded room. It works, but it's noisy and can be easily overheard. Quantum networking takes a radically different approach. Instead of shouting, it whispers, using individual photons to carry information. This is where things get really interesting. At the heart of quantum networking are two mind-bending principles: superposition and entanglement. Superposition allows a single photon to exist in multiple states at once. Imagine a coin spinning in the air. It's both heads and tails simultaneously until it lands. A quantum bit, or qubit, encoded on a photon can be both a 0 and a 1 at the same time. This exponentially increases the amount of information a single particle can carry compared to a classical bit, which can only be a 0 or a 1. Then there's entanglement, which Albert Einstein famously called spooky action at a distance. When two photons are entangled, they become linked in a profound way. No matter how far apart they are, measuring the state of one instantly influences the state of the other. If one photon is measured as spin up, its entangled partner will instantly become spin down. This connection is instantaneous, seemingly faster than the speed of light. It's this spooky link that forms the backbone of a truly secure and powerful quantum internet. Now, let's talk about the game-changing applications. The most immediate and profound impact will be on security. Have you heard of quantum key distribution, or QKD? It's a method for creating unbreakable encryption keys. Here's how it works. Two parties, let's call them Alice and Bob, share a key encoded onto a stream of single photons. According to the laws of quantum mechanics, the very act of observing a quantum particle changes it. So, if an eavesdropper, let's call her Eve, tries to intercept and measure the photons, she will inevitably disturb their quantum state. This disturbance immediately alerts Alice and Bob that someone is listening in. They can then discard the compromised key and generate a new one. This makes quantum communication fundamentally secure. No matter how powerful a computer an attacker has, they cannot break the laws of physics. This isn't just theory anymore. Researchers and companies around the world are already building quantum networks. In China, there's a 2,000-kilometer quantum communication line connecting Beijing to Shanghai. In Europe and the US, cities are being connected with quantum links, creating metropolitan testbeds. These early networks are like the ARPANET of the 1960s, the precursor to our modern internet. They are laying the groundwork for a global quantum web. But the revolution doesn't stop at security. The quantum internet will also enable distributed quantum computing. Imagine connecting multiple small, less powerful quantum computers together to create one giant, super-powerful quantum machine. This would allow us to solve problems that are currently impossible for even the world's fastest supercomputers. We could design new wonder drugs and materials, molecule by molecule, create far more accurate climate models to combat global warming, and revolutionize financial modeling and artificial intelligence. Another incredible application is in the field of sensing. Quantum-enhanced sensors could achieve unprecedented levels of precision. We could build networks of entangled sensors that could detect faint gravitational waves with greater accuracy, create super-resolution telescopes by linking observatories thousands of miles apart, or even build medical imaging devices that can see biological processes at the cellular level without being invasive. Of course, building a global quantum internet is not without its challenges. Single photons are incredibly fragile. They can be easily lost or absorbed as they travel through optical fibers or the atmosphere. This signal loss, or decoherence, is the biggest hurdle. To overcome this, scientists are developing technologies called quantum repeaters. These devices would act like amplifiers for the quantum signal, catching and retransmitting entangled photons without destroying their delicate quantum state. Developing reliable quantum repeaters is the key to extending quantum networks over continental and even global distances. Another challenge is creating the hardware. We need efficient single-photon sources, ultra-sensitive detectors, and quantum memory to store and process quantum information. These are all active areas of research with new breakthroughs happening all the time. Scientists are experimenting with everything from diamonds with nitrogen vacancy centers to trapped ions and superconducting circuits to build the components of the quantum internet. So, where are we heading? The quantum light revolution is a multi-decade endeavor. We are currently in the early stages, much like the beginning of the classical computer age. First, we will see specialized point-to-point quantum links for ultra-secure communication between banks, governments, and military bases. Then, as quantum repeaters become a reality, we'll see the emergence of larger networks connecting cities and countries. Eventually, this will evolve into a full-fledged quantum internet, operating alongside our classical internet, handling tasks that require its unique power. This future isn't a distant science fiction dream, it's being built in labs right now. The quantum light revolution represents a fundamental shift in how we think about information and connectivity. It promises a world with unbreakable security, unimaginably powerful computation, and sensors that can perceive the world in a completely new way. It's a new frontier, powered by the smallest, most fundamental units of light. The journey will be long and full of challenges, but the destination will redefine our digital world. Thank you so much for joining me on this deep dive into the quantum future. If you're as excited as I am about this technological revolution, make sure to hit that like button and subscribe for more content on the science and technology that is shaping our tomorrow. Let me know in the comments what application of the quantum internet excites you the most. Thanks for watching, and I'll see you in the next one.